So, dear students, today we are going to study polysaccharides. And polysaccharides, polysaccharides are simply glycans. Consists of these polysaccharides or glycans consists of consist of repeated repeat units of monosaccharides or their derivatives held together by glycosidic bonds. Polysaccharides are linear as well as branched polymers. Polysaccharides are linear as well as branched polymers. And depending upon the components, the polysaccharides can be of two types. So these are of two types. Homopolysaccharides and heteropolysaccharides. So polysaccharides can be also better defined as the chemicals or biomolecules which can be broken into monomers upon hydrolysis. So they are actually polymers, and they are made up of the many units called monomers, which can be linked together by means of the glycosidic bonds. And these bonds can be formed between the carbon number one. They can be linear and are and at the same time they can be branched, so linear as well as branched. So depending upon the composition of that, whether it's made of similar kinds of units or different kinds of units, these are of two types: homopolysaccharides and heteropolysaccharides. So as far as homopolysaccharides are concerned, they upon hydrolysis yield a single type of monosaccharide. Homopolysaccharides, these upon hydrolysis yield only a single type of monosaccharide they are named on the nature of monosaccharide unit like you can say they can be called as they are known as glucans, polyglucans if they are made up of they are polymers of glucose. Fructosans, polymers of fructose. Fructosans. And similarly, heteropolysaccharides, they upon hydrolysis yield a mixture of a few monosaccharides or their derivatives. Upon hydrolysis yield a mixture of a few monosaccharides or their derivatives. Monosaccharides or their derivatives. So this is about the homopolysaccharides and heteropolysaccharides. Let's take up now homopolysaccharides. So homopolysaccharides, again, I would like to upon hydrolysis these upon hydrolysis yield only a single type of sugar. In this category, there can be, suppose there can be now, it can be polyglucans, polyfructosans, etc. And here I'm providing an example of starch, glycogen, and cellulose. These are the examples of the homopolysaccharides. Three main types of the homopolysaccharides, and there's a one more which is called inulin. So these are the examples of polyglucans, And inulin is an example of polyfructose. Polyfructose. So this is about this. So starch, glycogen, and cellulose are polyglucans, and they are examples of homopolysaccharides. And inulin is a polyfructose, again a homopolysaccharide. Um, let's talk about first today about starch. Starch is a carbohydrate. It's a reserve food material in case of the plants. It is a homopolysaccharide component, and it's a homopolysaccharide, and is made up of only glucose units. Starch is a reserve food material. Starch is a reserve food material in case of plants and is stored in the plastids called amyloplasts. High content of starch is found in tubers, roots, cereals, etc. And so far as the structure of the glucose is starch is concerned, starch is made up of two components. It's made up of one of the component known as amylose, another is amylopectin. Amylose and amylopectin. Amylose is 15 to 20% and is a water soluble. It is a water soluble component of starch, whereas amylopectin, it forms 80 to 85% of starch and is water insoluble. Water soluble and water insoluble. Chemically, amylose is a long unbranched chain with 200 to 1000 units of alpha D glucopyranose linked together by alpha 1,4 glycosidic bonds, whereas amylopectin is a branched chain is a branched chain with alpha 1,4 bonds, alpha 1,4 glycosidic linkage alpha 1,4 glycosidic linkage everywhere except at the branch points. There is alpha 1,6 linkage. So these are the two main differences between amylose and amylopectin, and both amylose and amylopectin together make the starch, whereas the amylopectin is made up of a few thousand glucose units. Made up of few thousand glucose units. Is made up of a few thousand glucose units, whereas 20 to 30 glucose units per branch, with 20 to 30 glucose units per branch. So the structural difference between the two is, so in case of amylose, this is the alpha 1,4 linkage, to OH, H, this is OH, H, and this is H and OH, this is H and OH, this is K again, H, it's linked by next glycosidic bond, this is next glycosidic bond, and H, CH2OH. So this is the structure of amylose, and as far as the amylopectin is concerned, the amylopectin will be having So he's having a linear chain, and in case of amylopectin, OH, OH, H, H, OH, OH, and H. This is H, OH.